Today we're wrapping up our EHS training blitz for you guys. This is the third module. When you came in this afternoon, you grabbed a quiz that is for the third module, and we're going to start off right into the environmental side of the training. Okay? As you well know, environmental is something that is very near and dear to RXO's heart, simply because of all the stuff that we do. We generate wastes. Okay? We have swarf that we generate. We have various chemicals that we use in our processes, and we try to make sure that none of that gets outside the building and adversely impacts the environment. All right? So, first off, we have a stormwater program, right? Within that, we have a permit that's issued out by the EPA and the Georgia Department of Environmental Protection. And in that, it basically says that it's going to rain in this area, right? We all know it rains, okay? But what we have to do is we have to ensure that there's nothing on our grounds, that when that rainwater comes in and goes off our grounds, that it doesn't take anything with it. So we're always looking to make sure that we're not polluting the environment from any chemicals that might be in parking lots or oils, grease, anything like that, okay? We do monthly inspections for this as well to make sure that we are staying in line with the requirements of the permit. And we also do wet weather sampling as well. All right, so we will purposely look for when it rains, and we'll come out and take samples of it just to kind of see what's flowing. Okay, we send that out for analysis, and then they report back to us, and we're able to determine if we are if we need to do anything to help protect the environment any further. All right. Currently, we are doing a couple extra things from our stormwater standpoint. We're looking at getting a new type of compactor in downstairs that doesn't have the. It's more enclosed and sealed up, so anything that goes into it stays inside of it. So none of it actually comes out of it and impacts the ground around it. All right. We're also looking at additional types of filtration devices that we can put outside, maybe just prior to it going into our stormwater outfalls. That's still kind of up in the air, but we are doing quite a lot of things to help protect the environment. We also have a spill prevention plan. All right. That's also required by the EPA, okay? With that, we have to do monthly inspections on that as well. We have to make sure that we are not polluting the environment by spilling stuff that gets outside the building, all right? Or anything that might get down a drain or anything like that, right? We never, ever, ever pour anything down a drain, right? Bobbleheads, yep, okay? Just like an incident report, every spill has to have documentation that goes with it. So we already tell everyone that if you have an incident or you have a cut, a scrape, an ache, a pain, something like that, we want to make sure that's documented so you're taken care of. Same thing applies to the environment. We want to make sure it's taken care of as well. So we have to document everything. Okay? We have spill kits that are located various spots up here on the second level, and we have a couple other ones downstairs over in the pad print area. For our purposes, our spill kits are going to be in the consumables room. Okay, that's where they're going to be located. We also have them, like I said, downstairs in the pad print area. They're also around the generators. Okay, to make sure we can clean up any oil spills, fuel leaks, things like that. Whenever you see a spill, make sure you notify the supervisors right away. Right, isolate the area, keep other people from walking into it. Right, we don't know what it is until EHS can come up there and validate what it is. All right. For example, if you see a liquid on the ground, right, and you walk up to it, do you know that liquid is water?
No.
No. All right. Do you know if it's isopropanol? No. Not necessarily. You might smell it, all right, but you still don't know if it technically is isopropanol on the ground in front of you. All right. Both are colorless liquids. Okay. So what we need from you, from that spill incident report, is we need to know how much was spilled, or what was spilled rather, how much and at what time was it spilled. Because we have to account for anything that evaporates from it as well. When you're cleaning anything up, you want to make sure that you know what that chemical is. Right? And you can further enhance your knowledge of that by looking at the safety data sheets. Right? We've already talked about some things in the past about safety data sheets and HAZCOM. Just kind of rehashing that for you guys so it really sticks with you, right? The safety data sheets will tell you everything you need to know about that chemical, right? It tells you literally any type of first aid measures that are involved in it. It tells you how to clean it up. It tells you how to protect yourself, whatever type of PPE that you might need, Okay? There's an example of where we keep our gear. We had in building 2, the kits are in the consumables room, second floor, pad print, first floor, both generator buildings. They look like that little yellow container. All right? Inside of that is going to be a wide variety of different things that are used to soak up different types of product, whether they soak up oil exclusively or if they soak up a universal type of product. So they'll pick up water, acids, bases, anything else. Within those kits contains what they call socks or booms. All right? They're basically really, really long tubes, and they're packed with a material that looks like cotton. All right? They're tied off at the ends. Those are called socks or booms. We have absorbent pads. We also have the container itself can double up as an actual spill response piece of equipment. So if we spill anything that's of a significant amount, so say over 5 gallons, we're going to start using these big kits to clean it up. What we can do is we can empty out all the contents of it, and then all the cleanup materials can then be put into that, and we put that little screw top closure on it, and then we can ship that off as part of the waste shipment. All right? For small spills, we're going to use our little 5-gallon pails, right? As long as it has a top on it that can close. And at that point, we're going to make sure we use up any type of spill cleanup materials like pads or wipes or anything like that. Those all go into that bucket. That bucket has to be labeled appropriately and then given to EHS so we can dispose of it. Spill procedure itself is pretty easy. Right? First thing, you're always going to make sure you protect yourselves before you go and try to clean something up. All right? You want to contain the spill. Keep it from spreading to other areas. If it's less than 5 gallons, we're going to clean it up with paper towels or wipes, put it into a 5-gallon bucket, and we're going to seal that bucket up. We're going to label it appropriately, get it to EHS. For anything over 5 gallons, like I said, we're going to use the big kits. Pad print spills, they actually have a pad print waste container downstairs on the first floor. You see here we have Jamarcus, and he's demonstrating how to clean it up. Right? He is using an appropriate set of gloves, right, protecting himself. He's wearing safety glasses as well. And he's wiping up the product on the floor, keeping a bucket nearby so he can then slide it into the bucket, rather than try to pick up all of those wipes and carry them somewhere where you're dripping it across the floor, and then you're cross-contaminating a wider area. All right? So he brought the bucket to it, the wipes, everything goes into it, seals it, then it goes off to EHS. We have 5 waste streams here. All right? The first one is hazardous waste. Second one is recyclable materials. Third is reclaimable alloy. Fourth is universal waste, and then there's non-hazardous waste. All right? So we pretty much run the gamut of everything there is when it comes to waste and recycling that we do here. Here's an example of what we do with our hazardous waste. Okay? Everyone has seen the orange buckets out on the shop floor and modular area, right? Okay? Those orange buckets are labeled with a hazardous waste label on the side of it. Okay? Inside of those, what we can put in those, we can put DVA filters, waste lenses, lens tape, and our purple nitrile gloves that we use, right? All those things can go into the orange containers. Okay? Whenever you're done putting something in those orange containers, please make sure that you put the lid back on it. All right? That's there to help protect you and prevent anything from getting spilled out of it, where then we have to now clean it up, and it creates a wider area of a spill to clean up. All right, so what is the hazard? All right? We have alloy contaminant materials exceeding landfill limits for lead and cadmium. All right? So we can put product in these, and then they're shipped off for disposal. We cannot put them in a landfill because the landfills will not take it because of the lead and the cadmium content in the alloy. All right? Because it'll leach out of the alloy into the groundwater, and it starts to affect the local population. All right? So we have to dispose of it as hazardous waste. All right? So the buckets themselves, like I said, you have the tape, the gloves, the waste lenses, not alloy or towels. All right, and I'll show you a difference on that in a second. Okay, so they have everything. You notice the picture here on the top, on the left. It's inside its little lined out area where it's supposed to be on the lines, and of course it's closed. Picture on the right shows a consolidation. So what they're doing is they're taking everything from these small 5-gallon pails and dumping it into a larger 55-gallon drum that's set up for that process. Okay.
Question between this slide and the 1-2 back where it said we could do the DVA filters also?
DVA filters won't fit in the small buckets.
Okay.
All right.
But it's the same.
In theory, if they were small enough, they
Okay.
could be placed in there based on that.
Okay.
I'm going to show you where they go in a second.
Sorry to interrupt.
No worries. So When full, empty the 55-gallon drum into each, or take it into each sort room, and that way we can take care of it, seal it up, and get it off-site for disposal. The lid's got to stay on the bucket at all times, and the bucket has to have a hazardous waste label on it. When you're out there on the lines, make sure when you're walking past it, look down at those buckets, especially the orange ones, make sure it has that label on it. And it's got to be filled out. It just can't be a plain label. It's got to have writing on it. It basically spells out what goes in there. Okay? The DBA filters, all right, they go into the cubic yard box containers. All right? We have one that's right by where line 1 would be, adjacent to line 2, right? And the filters have to go inside the liner that's in the box, right? So you physically have to open the box lid, open up that big plastic bag that's in there, then put the DBA filters in that, then close the plastic liner on top of it, and then close the box lid, right? And we do that because anything that's liquid that might still be into it, if you don't put it in a plastic bag, you just lay it on top of it, it's going to run out, and it's going to get inside the actual cardboard, it's going to ruin the cardboard, we have to start the whole process all over again. Plus dispose of that cardboard then, okay? So, spill procedures, all right? Whenever we're going to deal with anything from a hazardous waste standpoint, we're going to wear gloves when we're handling it, okay? Always wear gloves. Make sure the gloves have no holes in them too, all right? They got to be in good condition. We don't want anybody being exposed to anything. When a cleanup kit is used out of the consumables room, we have to be notified about that. We cannot just use it and put it back. We have to restock it, all right? So you have to let us know what has been used out of it. Any of the debris that's associated with a spill cleanup, it can get put back into the yellow container, and we dispose of that, right? But again, if you use anything from a spill response standpoint, let us know so we can restock it for you, okay? So we have different types of other materials. We have ignitable waste, all right? Ignitable waste are going to be waste aerosol cans, any of the pad print area waste, which could be paint thinner, various chemicals like that they use down there for pad print. Currently, the engraving area uses isopropyl alcohol as well. Right? So all those are considered to be ignitable wastes. They're called a D001 ignitable waste. That actually is what has to be on the hazardous waste label. Okay, so that's what's going to be physically on the little bucket, or the small pails of it, or a large drum. All right, it'll say, if it's ignitable waste, it'll say D001 flammable or ignitable waste. Okay? Within that, what that means is that the liquid has a flash point of under 140 degrees Fahrenheit. Right? So anybody ever been to the gas station, accidentally overpumped your gas tank? Gasoline hits the ground, you turn around, you turn back, you look at it, it's already gone, it's evaporated. Right? Similar concept. Right? If it's got a flash point less than that, it's more readily to evaporate very quickly. Okay? Solids that can cause a fire or sustain combustion. Right? That's something else. It's considered ignitable waste. Ignitable compressed gases and oxidizers. All those fall into that category. So this is what we do with waste aerosol cans. Right? Waste aerosol cans do not go in regular trash. Ever. Okay? They have to be taken into the swarf room, and there's a drum there. It's got the hazardous waste label on it, and on the top of it's written waste aerosol. Okay? So, what is waste aerosol containers? Spray paint, right? WD-40, any type of lubricant, right? Also looking at any type of spray cleaners. Okay, that's also considered to be ignitable waste. It'll say right on the label on the side of it, dangerous, flammable, something like that. Okay? Other things we don't throw into the regular trash can, the little compressed air that you use for blowing off your keyboards and that kind of thing, that does not go in the trash either, that goes in this. Okay? The reason we put the whole container in there is because we don't puncture these things anymore. There used to be a belief that you could puncture them, contain it, and drain everything out of it, and then dispose of the can in normal waste streams, and everything gets caught up inside the drum. But too many people involved in that tend to get hurt. Right? From personal experience, I saw a gentleman who was using this, can puncturer inappropriately, and instead of putting the can the right way, he had it flipped upside down, punctured it, the can exploded, and he turned blue, because it was blue spray paint. All right? Right? Luckily, he was wearing his safety glasses, so when he took them off, he had the raccoon marks. Okay? So that being said, we don't do that anymore. okay? And I don't want anybody to do that at home. Don't try to puncture a can of something at home so you can throw it away. You're gonna get yourself hurt. Once you're done putting something in there, you're always gonna put the lid back on. I'm not saying you gotta tighten that ring around it, right? But you gotta put the lid back on to make sure that nothing comes out of it, all right? The pad print waste. All right, pad print waste goes into a red 5-gallon container. You can see it here in this picture. On the top of that thing, there's a hazardous waste label on it, all right? When the container's full, they notify EHS. Lid's got to remain closed on the container at all times. It's actually spring-loaded, okay? If there's ever a fire in one of those types of containers, they have a little fusible link in them so that when it melts and the fire hits it, it starts to melt out. The lid won't open. It pushes a little pin through it so the lid will not open. It'll help extinguish the flames internally, okay? It's a nice little thing that we have. If there's any spills associated with it, again, we're going to clean it up and make sure everything gets put in the appropriate containers, all right? Recyclable waste, we recycle towels, sponges, booties, any vacuumed up solids, like with the dry vacuums that we have out in Modulo, housekeeping debris, all right? That all started back in the first quarter of 2018, all right? We've gotten very good at it. We still can get better, but we've gotten good at it, okay? Since then, we've recycled 27,844 pounds of material. That's pretty good, all right? That's materials that are not going out and going into a landfill, materials that we don't have to send off for disposal at really, really high cost, okay? Those are things we've been able to recycle, and we've been able to do it appropriately where it doesn't affect the environment or you guys, all right? Everything but the TSA tape, the gloves, DBA filters, and waste lenses can be recycled, okay? There are blue containers for recyclable items only. The TSA tape, alloy contaminated gloves, DBA filters, waste lenses are considered to be hazardous waste. The recyclable waste. We have the blue buckets, right? We've all seen these out here in Modula 2, correct? All right. Blue buckets, they have the little sticker on the front of it that says recyclable waste. So a good thing to remember, blue buckets, where did we get them from? Look at the logo. Lowe's. All right. Orange buckets, where do you get orange buckets from?
Home Depot.
Home Depot. All right, so you can kind of help build that in your head. All right. Shoe covers, booties, towels, the sponges, all those items get placed in the blue containers. All right, that way we can recycle them. Here's an example. So at the end of each shift, we're going to we're supposed to switch out our blue buckets online and then make sure that we consolidate that waste into the larger drums. Okay? So you'll have, as you start to fill these small buckets up, you'll then take it, stage it, then from the staging area it gets dumped into the larger 55-gallon drums. Once those get filled up, then they get sent out for recycling and reclamation. Okay? Buckets are always segregated to make sure that we're not putting anything accidentally in the waste stream. Okay? If we take one little bit of hazardous waste and it gets put into a blue bucket, that whole bucket becomes hazardous waste. If that blue bucket isn't checked before it gets put into the 55-gallon drum, then that whole 55-gallon drum becomes hazardous waste. All right? See where I'm going? It could be something very, very small that turns a whole drum into hazardous waste, and it costs a lot more money to dispose of something as hazardous waste than it does to recycle it. Okay? So, alloy is a raw material that we use in our lens making process. Right? Everyone should be relatively familiar with the process at this point. Okay? It costs $37 per pound. Okay? If you look at this little remote control that I have in my hand here, this is about the size of one of our little ingots of alloy when it's in its raw state when it comes out of the consumables room. This would weigh 1 pound. This would also cost $37 per unit. All right? We make sure that we recycle and reclaim as much alloy as we can, because if you add it up, it becomes very expensive very quickly. Okay? We had an incident not too long ago where we had alloy that was put into a 5-gallon pail, and it was left over by the swarf room, and then I don't know how everybody got it there, but it was extremely heavy. The bucket itself weighed about 400 pounds. All right? Yeah. So the equivalent of 400 ingots of alloy in that bucket times $37 a piece, if you crank out the math, it's $13,000, $14,000-ish. All right? That's a lot of money just to be thrown away. Right? So that's why we have a very aggressive reclamation program. where this material goes into, we put it back into the reclaim tanks. We try to get that stuff to melt back out, drop out. So we take care of the product, all right? And we make sure that it does not get sent out as waste. If we do have some that's sent out as waste, right, it's usually because it has thermally degraded. It's gotten above 143 degrees, where it's no longer usable in our alloy process, okay? When that happens, we ship it off-site, and we have a recycler that will give us a percentage of that back from what they reclaim. But it's not nearly as much as what we spend on it to get it. Like I said, we spend about $37 per pound of it. We only get about 1/3 of that, about $12 back. Okay? So it's in our best interest overall to reclaim it internally. Universal wastes. All right? Universal wastes have a wide variety of different things that make it up. All right? It is still hazardous, okay? But it's to a little bit lesser of an extent. Okay? The way we dispose of universal waste is we still will package it up appropriately. It'll be labeled with a universal waste label, and it's sent out where they recycle that material. Right? Some examples of universal waste, if you look straight up above you, all these little lamps, these tubes, right? These are all considered to be universal wastes. Okay? The batteries that I have in this remote control, if I can get the lid off. These batteries are all considered to be universal waste. Okay? These are alkaline batteries. We are allowed to dispose of alkaline batteries in our homes, right, in small amounts. Okay, so if you have a flashlight, your batteries go dead, legally you're allowed to dispose of those batteries in your home, all right, in your trash stream. Okay, but because we are here, and if every person in this room had a flashlight and all those batteries went dead at the same time, right, you're looking at a lot of waste that would go out. So it has to be categorized as universal waste. So all the different types of battery powers, right? We have the alkaline batteries. We put into a bin, a segregated drum like that. We have lithium ion, NiCad. All those different types of batteries are kept separate from each other, and then we make sure we recycle them appropriately. Also, anytime that if you guys have any type of lithium ion or the NiCad batteries that you're going to put in here, or if you're going to dispose of them at home, make sure that you put some electrical tape over the terminals. Right? Even though a battery might be dead, there's still some juice in it. So if you get those terminals and they touch together, they'll weld themselves together. Right? It bonds them together, and what you'll end up with is it'll generate a lot of heat, and that could create a fire. Okay? All right, waste lens polish. Waste lens polish is considered to be a non-hazardous waste. What we do with this is as we bring it off the lines, right? We take it over and we put it into the drum that's in the swarf room, and it says on there waste polish, non-haz. What we do from there is we take parts of that and we add that into our wastewater treatment plant. Right? We're able to make sure that it's treated internally, and then we're able to send it to our the wastewater treatment plant for Henry County, which is a few miles away. Okay? And it doesn't do anything adversely to affect the environment. Okay? We have here also used oil and oily rags. Right? Remember the term used oil. Right? If we say waste, it connotates that there's something hazardous, a little bit more about it. So it's used oil, oily rags, used rags. Okay? Those are all put into a separate drum, all right? Labeled as such, used oil, oily rags. All right? Again, located in the swarf room. All those go in there, the lid goes back on top of it. That is, again, when it's full, it's sent out for recycling and for reclamation. Typically, they'll use it for, they'll try to clean it up and reuse it as a recycled oil, or they'll use it in energy reclamation projects. So they'll put it to a cement kiln and generate energy from it. We also use the waste heat transfer fluid. Okay, so if you're familiar with the tinting process, it's very similar. If you've never worked over there, a lot of people own crock pots. Right? Crock pots, you put the crock on top of it, you put a little water in between it, that way it stays nice and hot, right? Similar concept. The waste heat, the transfer fluid goes between the heating element and the actual stainless steel pots that are put in there for the tinting. Okay? At a certain point, that transfer fluid is spent, and we have to get rid of it. So we also put it into a drum right there, then when it's full, we recycle it and send it out. All right? So we also have a wide variety of empty drums. Right? We generate empty drums when we completely use, whether we're using the cutting fluid, the synth cut, or we finish up using a drum of isopropanol. Okay? So we have to, when they're considered empty, is when they're about an inch from the bottom. They're considered to be RCRA empty. RCRA stands for Resource Conservation and Recovery. Okay? So what that means is we have to label it, put on there RCRA empty on it, like I said, less than an inch of product in it. Then those get taken back to the storage cage right over here in the corner of the building, on the southeast corner of this building. Okay? From there, Glenn, Jamarcus, they'll take care of it, make sure that it gets shipped off site whenever we have enough of a load to send it out. Okay? Other waste we have swarf. We also have spent bead blast media. Right? Those are considered to be non-hazardous waste. Right? So currently, what we're doing is we are putting them into the trash compactors, all right, and sending them off-site into the landfill. We have goals that we're trying to accomplish to remove additional material from the swarf to make it drier. All right? As we do that, we're able to compact it and turn it into these little briquettes, and then we're trying to have somebody, usually a plastics recycler, be able to come in and take it off our hands. Okay? That way we're not putting something in the landfill. All right? So we're working to try to get that done. Columbus is currently working on a densifier project, and we're trying to see if we can get that here as well. All right? If you look at the bead blast, right? The bead blast is very simply, it's the when it's spent, it's done being used, it's all vacuumed in with the Donaldsons, right? And it's a dust collector. It brings it all, drops it into a 55-gallon drum. Then that's sealed up, and then they take it downstairs, and that's dumped into the trash compactor as well. I just today delivered a drum dumping device that's inside the media blast room now with a work instruction that's in development. I'll have it filed down here by Monday. And that will aid everybody, whoever's assigned to that area, to dump those drums out. You won't have to tip them over anymore. You hook them up to this portable unit, and it basically does all the work for you. All right, it's extremely easy to use. It'll minimize the risk of shoulder and back injuries. Okay, so if you do work in that area, check it out. All right. Over in logistics, the pad print waste that they have over there, they actually have a good size flammables cabinet. Bright yellow, says flammable on the outside. Inside of that, they have a little waste container that's that black one there on the shelf that's labeled appropriately with hazardous waste on it. Anything that they generate from the pad print area, where they're actually printing stuff onto the arms of the eyeglasses or whatever, that all comes over here and gets stored. Okay? Anything that is ever put in there, we make sure that as it gets filled up, we dispose of it appropriately. But also anything that goes into a larger container, like a flammable cabinet, you always want to face that label so it's facing out. So you don't have to reach in and move it around. All you have to do is open the doors and you'll be able to see it right in front of you. Okay? Over in the engraving area, over in building 1, right, we have a small side pallet over here. Again, it has a 55-gallon drum with a flammable label on it. It is for ignitable waste because they use isopropanol over there. Logistics also has aerosol waste. We share the same thing we share with you guys. Nobody punctures waste aerosol cans anymore. They all go into a drum. Make sure that the lid is closed on them. All of our universal waste streams, like I said, we have our fluorescent light bulbs, lithium-ion and NiCad batteries, lead acid batteries from our emergency lights. If you look anywhere around the perimeter of the building, right, as you find a stairwell that's going down or in a fire exit that leads out of the building, they'll have an exit sign like these, but they'll usually have a little bit of like 2 lights sticking out of the top of it. Right? If we lose power, those lights will kick on, and they're provided power by those lead acid batteries. They give us about approximately half an hour of life, so we can see to be able to get out of the building. Right? When those batteries die, we have to recycle them as well. We have to take care of all of our waste that leave this building. We talked about that tape terminals already. So when it comes to the waste lamps, whenever anybody's replacing them, instead of throwing them right into the trash can like the old days, all right, what would happen is we actually take them and put them into a box. Okay? That box has to be closed up and has to have that universal waste label on it. If you look right below it, you have 2 small buckets there. Those 2 small buckets are basically for waste batteries. All right? And whatever they're labeled, again, you don't want to intermingle the 2 different types, or several different types. So you don't want to put a lithium-ion battery and an alkaline, or alkaline mixed in with a NiCad. Keep them all separate. Light bulbs cannot be broken. Okay, they got to remain intact. All right, so you can no longer take them and smack them with each other like little swords. All right, and I know people in this room are guilty of that because I did it when I was a little boy. Okay, so I know better now. Okay, but that being said, we have to make sure that we keep them in good condition, and we're very careful with them when we put them in the boxes for recycling. Okay, so if you look here, the correct one is up at the top, and it's properly labeled, and also the date that it was considered to be full. All right, the box there on the left with the X through it, someone left the box open, all right, and therefore it allowed anything that might be broken inside of it, to any of the product that was contained inside the bulbs, it allows it to come out. By keeping it closed, it keeps it enclosed inside that box. With the batteries, we make sure, again, we tape those terminals. If they're going to be like lithium-ion, NiCad, we don't want those things touching off and causing a fire. Any of the battery lids, we got to put them back on. All right, you can't just leave them off to the side or barely on. They got to be completely covering it. All right, next topic is going to be called what's hazard communication. All right, globally harmonized system. A few years ago, the U.S. had it. Well, U.S. and North America had their own way of doing things when it came to labeling product. Okay, the rest of the world had been doing it the same way for some time. All right, the U.S. and Canada all came into alignment with the rest of the world, creating this globally harmonized system. So what that means is if a chemical comes from Korea and is shipped here, we'll be able to identify what the hazards are in it based upon looking at the symbols and looking at the information provided, right? Rather than have to search it out, okay, or look at a different methodology. It's also covered from our right to know, right? That is your legal, our legal as the company, it's the company's legal requirement to educate you on what's called right to know, right? You have the right to know any chemical in the workplace. You have the right to look at safety data sheets, to have training to understand it. And then you have the right to any type of medical information that might stem from it. Say you might have an exposure. At that point, the company has to maintain those records for you. Right? Now again, those would never be shared with anybody other than you. All right? So we maintain those records for long term. So the elements of a HazCom program is a written program. Right? That's available online in our shared drive. Right? Anybody can look at it whenever they need to. There's a hazardous chemical list. Right? We maintain a list of all the various chemicals that are hazardous. We also have our labeling. Right? The labeling on individual containers that come in that we buy, plus secondary containers. Okay? Secondary containers are anything that we transfer one chemical from a larger container into a smaller container. Those have to be labeled appropriately. All right? I'll give you an example of one that I saw that was improperly labeled not too long ago. There was a small consumer container of Simple Green, right? In its native form, it's fine, right? You can read it, tell you what's wrong with it. It was emptied out, and then someone wrote Pine Sol on it. Okay? That is the inappropriate use of a label. So what we've done is we've gone out and procured actual individual new labels. So we take those and we can sticker them right over anything, and you can write into it what it is and its hazards. Okay? So anytime we transfer from a larger container to a smaller one, we've got to make sure it's appropriately labeled. Safety data sheets. All right? They used to be called material safety data sheets. All right? Basically the same thing. It used to be MSDSs, now it's just SDSs. Okay? With this new realignment and becoming in line with the rest of the world, the safety data sheets now have to meet a minimum requirement. All right? Several years ago, you might get a safety data sheet that would be one page. Okay? And it had a little bit of information on it, and that's all you got. Now there's 16 sections that make up that, and there has to be specific data in it affecting you, the environment, transportation, everything else. All right? We're going to go over those in a minute. Employee training. Right? You have to have initial training, right, before you start working with any chemicals. Right? You have to have the annual refresher training, which is what we're doing now. Okay? And then on top of that, if we add a new chemical to our process, you have to have additional education on that. Right? Coming up in the future, we are expecting to add a new process off the AR road. You might have heard it, it's called a dip coating operation, right? That's going to have new chemicals are going to be introduced, right? And once they're introduced, we'll be getting back with you guys and re-educating you on those chemicals, right? Non-routine tasks, right? Now we try to have everything proceduralized, okay? That way you can follow steps, step 1, step 2, step 3, step 4, to make sure that you stay safe, right? If there's ever a non-routine task that crops up, there's extra levels of protection and caution that we need to take. If it's not proceduralized, we run the risk of exposing ourselves or other people, all right? So that's where it gets really tied into the safety data sheets. So the written program. The written program currently exists online in our shared drive. It used to look like this right here, right? There was a binder that said Hazard Communication Program. A long time ago, people would start to, it'd sit on the shelf and collect dust, and then people started using it to level tables when it got a wobbly table, right? So things like that would get lost, right? And it makes it very difficult to maintain those things. So by putting it on the shared drive, right, we can make sure that it's constantly up to date, and we can make sure that we can print out copies for anybody that wants them whenever they want. All right. Our campus, we have a spreadsheet that houses all of our chemical inventories for anything that's hazardous on site. Annually, we have to report in, all right, to the government as to what types of extremely hazardous substances that we have on site. An extremely hazardous substance would be something like sulfuric acid. All right? Sulfuric acid is inside forklift batteries. We have it nowhere else on the campus, but they're inside forklift batteries. Because they're in those batteries, we have to maintain that total annual basis. Okay? So those are some of the things that we already are maintaining that spreadsheet on, but then we're also using that to help complete our permitting process. The labels themselves, all right, the new labels are fairly easy to follow. All right? If you look over on the left-hand side, it says signal word. There are 2 signal words. One's danger, the other's warning. If neither of those 2 signal words are on there, the chemical is not going to cause severe issues with you. Okay? Danger is obviously the more hazardous of the 2. Okay? If you look across the top to the right, it says the product name or identifiers. It tells you what the chemical name is, carbon monoxide. Right? Underneath that, it has hazard statements. Those hazard statements are directly correlated to the signal word. All right? So if there's a danger signal word, the hazard statements that are going to be in there are going to be really kind of nasty. All right? They're going to tell you right up what it does to you. All right? So for example, this one here says H220, extremely flammable gas. H331, toxic if inhaled. All right? Those are all good information to know, right? All right? We all want to be able to walk out the door at the end of the day and not have any adverse effects. Okay? Just underneath that is what they call precautionary statements, called P statements. All right? Those give you additional information about the chemical, how to protect yourself, what to do in case of an emergency or you need first aid. All right? Just underneath that, or somewhere on that label, there will be information about the manufacturer. All right? It gives their manufacturer's name, their address, 24-hour contact information. Okay? So if there's ever an incident with that particular chemical, you can look at that label, use your phone, call it in, and they can walk you through additional information on that chemical. All right? We have a legal requirement to help maintain those. The one on the lower left-hand side, see all the different symbols, right? They're icons, pictograms. Each one has a different meaning, and there's about 12 of them. Okay? If you notice the top one there, it looks like something's on fire, right? It means it's flammable. Okay? The one down and to the left from that, what's that look like?
Dynamite.
Huh?
Dynamite, explosive.
It's actually a compressed gas cylinder, right? But it can react that way if it's punctured. Okay? But that means compressed gases, right? Wide variety of different ones. The one to the right, skull and crossbones.
Deadly.
Toxic, poisons, pretty easy, right? These are, as you can see, I'm going down this road here. These are very, very intuitive. The one underneath, what's that look like?
Respiratory?
Could be respiratory. It's health issues, causes health hazards. Okay? Looks like a gas kind of spreading across the front of a silhouette. All right? Now with the labeling, I was just telling you guys about the secondary container labels, right? That we transfer from a larger container to a smaller container, we have to label. We use what's called the HMIS system, Hazardous Materials Identification System, all right, on those secondary labels. That's there on the left-hand side. We're able to write in the chemical name, its health hazard number, the flammability, physical hazard, any PPE that might be recommended to handle that particular chemical with, all right? The hazard ratings for the HMIS system go from 0 to 4. 0 being virtually no hazard, completely minimal, all the way to 4, which is the worst. If you look at it wrong, it could do you damage. Okay? So that's for those labels. Now there's a little bit of a difference with that. With the GHS labels that we get on the big containers, they're labeled the opposite. All right? So a 1 is a severe hazard and a 5 is a minimal hazard. They're completely inverse. All right? So you have to keep that in your head when you're looking at these labels. If you're looking at a label, a GHS label, and you want to apply an HMIS label to a secondary container, don't assume that the numbers are the same. Okay? If it has a minimal hazard on the GHS label, it's going to be a 5. Right? If you put a 5 on an HMIS label, 1, it's wrong because it only goes to 4. But the higher the numbers you get on a GHS or HMIS label, the worse it is. Okay? So you have to keep that in your head. Now there's a real nice way of being able to check all this out without being confused by it. And that's actually look at the safety data sheets for that chemical. It actually tells you in section 16, the last section of the safety data sheet, it usually tells you what the HMIS information is. It does the work for you. All you got to do is copy it. All right? The GHS icons, right? I think I told you there's about 12 of them. Notice at the top here for physical hazards, you have explosives, right? It looks like a little ball that's exploding, okay? The one underneath of it, it looks like something's on fire, right? Comes off the flat surface. The one after that looks like a ball that's on fire, right? What else looks like that ball?
The letter O.
The letter O, right? What starts with O? Oxygen, oxidizers. That's what that stands for, okay? After that, that little thing there that looks like a stick of dynamite is for compressed gases, right? The one underneath of it is corrosives. That one hasn't changed. Health hazards. You have the skull and crossbones, toxic, poisonous. You have an exclamation point now. The exclamation point means it's harmful or it's an irritant. It's designed so if you see that exclamation point, it wants you to read to see what it is. Because an irritant can make you cough. It can make your eyes water and tear up. It can have a wide variety of different effects on different people. All right, so you definitely want to read that information. And then, of course, there's a health hazard with the silhouette and the cloud spreading out of the chest. Those are all the different health hazards associated with that chemical. The last one here we have is environmental hazards. It's a dead tree and a dead fish, right? It's pretty self-explanatory, right? Okay, that means it's going to be environmentally toxic. All of our safety data sheets, okay, they used to be kept in that little binder that you see up in the upper right-hand corner. Everything used to be in that. And just like the actual program, it ended up under the corner of a table, right, making sure that it didn't wobble the table, right? So where we keep everything now is we keep it in a program that we have online called SiteHawk. S-I-T-E-H-A-W-K. SiteHawk. All right? There's an icon. If you look at here, this on the right-hand side, that picture right there on the right-hand side, it looks like a little hyperlink with SDS under it. That should be on every single computer desktop for any of our Luxottica computers. All right? All you have to do is you double-click on that. It takes you right into a website. It's SiteHawk. And you have unlimited access to go through the chemicals in there and read about the chemicals. And all you have to do is you go up to the search bar at the top and you type what the chemical is. If you're curious about isopropyl alcohol, you type that in there and you click the little search button on the side of it. It gives it a second, it pops up, and it'll give you the ability to click on it to read it in its web format. Or you can click the little PDF icon, you click on that, and you pull it up, you're able to print it out. Okay? And they're usually set up to print to the local printers. Okay? So that being said, you have quick access to any safety data sheet that you might want to see. Okay? The second place that we store safety data sheets is we store them in the shared drive. Okay? So the shared drive, it's in safety in the public folder. Okay? And another subfolder inside that public folder is called hazard communication. You open that one up, there's another little folder in it, it says Safety Data Sheets, SDS. You click on that, it's got all the ones we have for the whole campus currently in that file. All right? We're always updating these things. Anytime we get a new chemical that comes in or someone wants to bring in a new process, part of that is they have to check with us, with EHS, to make sure that we're not introducing a really bad chemical into the workplace. All right? And if there is a way, if the chemical itself is really bad, we try to go back to the engineering group and say, hey, is there a substitute that we can use? Because there are some things that we really don't want here. All right? So, that being said, you have access to these things. You have access to them 24 hours a day, 7 days a week. Okay? Now, all of the safety data sheets are all in English. Right? They have to be published in the language of the country you're living in. Right? So, here they're in English. If you were to go to Sedeco and visit Sedeco, they'd be in Italian. Okay? All right, this is all the different sections for the safety data sheets. Like I said, there's 16 different sections of it. It's all standardized now. Every company has to do them the same way. All right? Makes it a lot easier to identify what the information that we really want out of that safety data sheet. The first one is going to have the identification. All right, it's going to tell you what the chemical name is, plus any contact information for that manufacturer. Number 2 is the hazards of the chemical presented on it. Right? Gives you appropriate warning information, the signal words, danger, warning. Composition and ingredients in section 3. It's going to tell you what makes up that chemical. All right? Just because this bottle of water, if this was a mixture of chemicals, right? What this would actually break it down to individual percentages, what the hazardous components are. Okay? So, beyond that, it's going to tell you anything else that it might be incompatible with. All right? It's going to tell you what it doesn't play nice with. First aid measures. These are very important to everyone in this room. Okay? It tells you exactly what you need to do if someone breathes it, if they ingest it, if they inject it. Right? It tells you everything. All the stuff that you need to get that person the appropriate level of first aid treatment that they need. The next one is firefighting measures. All right? How do you put a fire out when you're handling this chemical? All right? If you have an oil and grease fire, do you use water? No. All right? It'll tell that to you. Okay? Next one is section 6, accidental release. Right? What do you do in case of a spill? Right? What do you do when it first spills? What do you do after it becomes a large spill? It breaks it all down for you. Section 7 is handling and storage. Right? This one tells you exactly how this chemical is supposed to be handled in the workplace and when you're storing it for long term. The next one is exposure controls and PPE, section 8. Another one that's very important to everyone in this room. Right? It tells you what you need to wear from a PPE standpoint to protect yourselves in the workplace. Right? The next one is section 9, is physical and chemical properties. Tells you like the pH, its melting point, boiling point, things like that. Section 10 is stability and reactivity. Again, it goes back into a little more detail about this chemical and what it plays well with and what it doesn't play well with. Okay? I'll give you, for example, with that. Who knows what happens when you take bleach and ammonia and mix them together? Right? It makes chlorine. Yeah, you're right. You almost died. You can die from it. It makes chlorine gas. All right? So that would actually be listed on the bleach as safety data sheet and on the ammonia safety data sheet. Do not mix with bleach. Do not mix with ammonia. All right? Has toxicological information. What this is they do a lot of testing, usually on animal subjects, what level of exposure the rabbit can take, and then they correlate that to humans. Right? Obviously, we cannot test on humans. Right? We don't do that. That's not ethical. Okay? So, that being said, we have to test on something on it in order to know what it can do to us. Right? The next two are ecological information and disposal considerations. All right? You have ecological information is what it can do to the environment. Disposal considerations is how we are supposed to dispose of it legally. 14 is transportation information, how it's to be shipped from point A to point B, whether it's to go from a port of entry to come to here, or it goes to a supermarket or whatever. Right? It tells it how it's supposed to be packaged. Then, of course, section 15 is regulatory information. Is the chemical subject to any legal requirements here in the US? Is there laws like the Clean Air Act, Clean Water Act? Does it affect any of those, right? The last one, like I said, is Section 16. And this is where they're actually going to break it down and tell you about the HMIS labels, okay? If you flip to that Section 16, you want to skip everything else and just go to 16, you can open that up and take whatever you're transferring from a big container and put it in a small container, put that label on, and it'll tell you right there. You can copy it, word for word, number for number, okay? So you do have access to medical records, like I said, okay? Only to yourself, all right? You don't have access to anyone else's medical records, okay? Not even when it comes down to it, say you're married to someone, unless you give that person power of attorney, that's the only way that person would ever be able to get the medical records, right? It is protected. You are protected in that case, okay? We're not going to divulge any of that information out to anyone, okay? Any questions? All right, let's get into the test. All right, I do apologize, I didn't have enough pens. We did yesterday, and the whole box of them disappeared over the last night, so.
Go figure.